Next, we move on to see how a solar system is specified and manufactured at the AES plant.
Hi, my name's Callum McLennan. I'm the AES Technical Director. My role within the company is to design the systems, and generally after an initial inquiry it comes through to me. I'm then looking at details such as what size of store are we looking to heat, what is the dedicated solar volume of this store, what are any auxiliary heating systems that are going to be in place and how are we going to tie that in with the solar system. I'm also taking consideration for pipe runs, I'm taking consideration for geodetic height. This can then all be taken into our own software where we can then develop the system where we get the right pipe sizes, the right pump sizes, we can get a system that's going to perform and is actually going to deliver beneficial gains to the end user. AES can offer a full design service where we can specialise in bespoke systems which suit specific locations and specific requirements for the end user. So once we get the information from the end user for what they're looking for, we can make a system to suit. This can include a bespoke solar collector as well. So therefore we can then go into the manufacture of the system and make sizes of a greater variety than what you would typically find on the actual market. An example of a bespoke system would be the Lister Cooperative project. It was listed buildings and there was a set footprint on the roofs that we had to work to. Because we make our individual systems and collectors to suit, we could make the collectors that would fit the existing space and at the same time be of the correct size to actually deliver the energy requirements for each individual. This is a simple model of a solar water heating system. What we find, we have a hot water store, we have a solar pump station with controller, we have an expansion vessel, and all of this is connected with our main flow and return pipeline going to the solar collector, connecting at the top and the bottom of the actual system. Here we have the pump station. Within the pump station you have a number of key features. If I just... Starting at the top, we have a pressure relief valve, which is a safety device. We have a connection to an expansion vessel. We have a air release system built in. We have a check valve within the system which prevents any unwanted thermosiphoning occurring which would lead to losses from the system. We then have the pump, which is obviously key for the circulation of the heat transfer fluid. We also have a flow setter which controls the actual rate that the fluid is going to be circulating. One of the key parts of the system is the actual controller. With the controller is constantly monitoring the temperatures at the solar collector and also at the tank. Whenever there's beneficial gains to be had for the system, it will then switch on the pump to start the circulation and the heat transfer. AES tries to source as many of the other components required for the solar system as locally as possible. With this example here, we have a hot water cylinder that's actually coming from manufacturers in Fife in Scotland. The key feature of the solar cylinder is there's a coil which is located at the lowest part of the cylinder. By being located there, it's offering maximum benefit where it's getting the water at its coolest point as it enters the cylinder and is immediately bringing additional temperature from the solar collector to the hot water. It's important that the solar coil is located as low in the cylinder as possible. Therefore, it's providing the greatest benefits to the domestic hot water system. The most important factors to consider in the design of a solar collector are high solar transmission through the glazing, high absorption in the absorber plate, low emission in the absorber plate, and low heat loss from the solar collector box. Looking more closely at the absorber, you see there's a line of copper channels which allows the heat transfer fluid to go through the actual solar collector, taking the heat from above the roof down to the hot water store. When the copper channels are linked, it could be either in a header and riser arrangement or a serpentine arrangement. The completed absorber is then put into the actual solar collector box. With the solar collector box, we have insulation at the back and sides of the whole unit. With the absorber, we then insert the pipes for connecting to the flow and return, going right through the actual edge of the box. Coming down here, we then eventually see where we've got a plate for actually recording the temperature, which is connected directly to the solar controller, monitoring what temperature exists at the panel at all times. The AES solar collector will always have the same cross-section in its design. However, with bespoke collectors, we make different footprints in different areas purely to meet the needs of retrofit applications or the specific requirements of architects. Another thing that AES is taking into its design considerations is integrating the roofs into the roof surface. This is part of the work that we're undertaking with our new collector that we're also getting tested at Heriot Watt. The solar system is subjected to extreme temperatures. In winter time you have levels going down to -20, and in summertime at stagnation points there can be temperatures in excess of 180 degrees Celsius. Therefore it's important that you have the right antifreeze fluid that's used within the system. The front of the collector you have the solar glazing. With the solar glazing you're looking for high solar transmission. You're also looking for something that's going to be weather tight and durable. Solar collectors are out in the open and they're open to all the elements. And the actual system is going to be there for a prolonged period of time where it can be in excess of 20 years. The edging of the solar collector is aluminium. The aluminium is also weatherable, so it's not going to rust, and it's also very light. The AES collector is an exceptionally lightweight flat plate solar thermal collector. This aids the installer for when he's carrying out his installation, and it's also beneficial for the transportation of these